NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this example, we will rationalize a denominator that contains fifth roots. We will carefully follow the exact algorithm shown in the reference image and highlight each change as we go. State the nth root difference identity. Light bulb tip. Just like the difference of fifth powers, we have an identity that multiplies a short factor by a companion sum to yield a minus b. Multiply numerator and denominator by the companion sum for n equals 5. Thinking phase quick challenge. Can you write the 5-term companion that pairs with the difference of fifth roots? We now place that exact 5-term sum in both numerator and denominator. Use the identity to simplify the denominator. The product of the difference of fifth roots and its 5-term companion equals a minus b, which becomes x minus y. In this lesson, we will follow a precise algorithmic sequence to rationalize a denominator that mixes a square root and a fourth root. Our output will mirror the structure shown in the reference steps exactly. First, we show the word example, and then the problem statement in bold orange math. We start from the original expression, 1 over the quantity square root of x plus fourth root of y. Step 1. Multiply by 1 using the conjugate of the denominator. We multiply numerator and denominator by square root of x minus fourth root of y. Step 2. The product of a sum and difference is a difference of squares. Here, a equals square root of x and b equals fourth root of y. So the denominator becomes x minus square root of y. Step 3. Multiply by 1 using the conjugate of x minus square root of y. We use x plus square root of y over itself. Step 4. Apply difference of squares once more to the denominator. The product x minus square root of y and x plus square root of y equals x squared minus y. Apply the fifth root sum identity. The rule says it converts a product of two specially crafted factors into a simple summa plus b. We multiply numerator and denominator by the companion factor with alternating signs. Thinking phase quick challenge. Can you predict the 5 terms of that factor before it appears? Use the rule to simplify the denominator. By construction, the denominator becomes x plus y. Play button step 3. State the final rationalized form clearly. This is the simplified answer. Intuition. The 5 alternating terms mimic the expansion one would get if you symbolically multiplied to the 5th power. So all radical pieces cancel in the denominator, leaving a simple polynomial x plus y. The numerator stays as a neat alternating chain of. In this example, we will simplify a tricky cube root expression by following, step by step, the exact conjugate-like algorithm shown in the image. Here is the example. First, read the orange formula. Then we will apply the identity. Rule box. We will use the symmetric cubic factorization. If you multiply a sum of 3 cube roots by its companion factor, the result collapses to x plus y plus z minus 3 times the cube root of xyz. We will map cube root of x to 1, cube root of y to cube root of 2, and cube root of z to cube root of 3. Step 2. Multiply numerator and denominator by the companion factor. Watch the orange companion factor appear. Step 3. By the identity, the denominator collapses to x plus y plus z minus 3 times the cube root of xyz. Here, that is 1 plus 2 plus 3 minus 3 times the cube root of 6, which equals 6 minus 3 cube root of 6. Step 4. Substitute that result into the full fraction. Notice the same factor 6 minus 3 cube root of 6 appears in numerator and denominator, so it cancels to 1. Quick challenge. Could you predict that final green line before it appeared? If yes, great job. Final simplified result in green. Summary. We used the symmetric cubic factorization. Then we multiplied by the companion factor, collapsed the denominator to 6 minus 3 cube root of 6, and canceled the common factor to finish. Practice this identity on similar problems and try constructing your own companion factors. Thanks for learning with me today. In this example, we simplify a telescoping product involving radicals by using the classic factorization rule, a to the k minus b to the k. First, read the problem statement carefully. Strategy. We will multiply by 1, crafted as a product of geometric sums, so that each radical difference turns into x minus 1. The rule is a minus b times a to the k minus 1 plus a to the k minus 2b, And so on plus b to the k minus 1 equals a to the k minus b to the k. Here a is the kth root of x, and b is 1, so a to the k is x, and the entire right side becomes x minus 1. Now multiply numerator and denominator by the product of all needed sums. This is 1, because the same product appears in numerator and denominator. Watch the denominator. Each pair, the square root factor times its sum, equals x minus 1. The cube root pair also becomes x minus 1, and so on up to the nth root pair. Therefore, the whole denominator equals open parenthesis x minus 1 close parenthesis to the power n minus 1. After distributing those products, the whole fraction becomes numerator equals x minus 1 to the n minus 1 times the product of sums, and the denominator equals x minus 1 to the n minus 1. Now cancel the common factor, x minus 1 to the n minus 1. The result is beautifully simple. Therefore, the simplified value of the original expression equals the product shown in green. Read it as square root of x plus 1 times cube root of x squared plus cube root of x plus 1 times fourth root of x cubed plus fourth root of x squared plus fourth root of x plus 1, and so on up to the nth root factor. Quick recap. We multiplied by 1 built from geometric sums. Each radical difference paired with its sum became x minus 1. The denominator collapsed to a power of x minus 1, and it canceled with the numerator. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.